This video is to help you with finding the relationship between similar figures and their areas and their parameters. So looking at question 1, a scale drawing is of a backyard tennis court. The scale is 1 centimeter, represents 2 meters in real life. Part A, what is the scale factor from the drawing to the actual tennis court? So before I can find the scale factor, I have to convert the scale to the same units of measurement. So 2 meters, I have to convert into centimeters. That would be 200 centimeters. So now looking at the scale factor from the drawing to the actual tennis court, I would take the length in the actual tennis court, 200, compared to what it's represented in the drawing, which was 1 centimeter. Now I divide it out. The scale factor is 200. For part B, to find the actual area of the tennis court, I'm actually going to do this 2 different ways. So, first method, I'm going to find the new length, or the actual length, and the actual width. So, the actual length, I would set up my ratios. 1 centimeter in the scale represents 2 meters in real life, equals, in the drawing it was 10 centimeters for the length, and I'm trying to figure out the actual length in real life. I can solve it with scale factors or cross products. So if I do my cross product, 1 times x equals 2 times 10. So I get x equals 20 meters. Doing the same thing to find the actual width. Setting up my ratios. 1 centimeter in the drawing represents 2 meters in real life. I have 4.5 centimeters in the drawing, and I'm trying to figure out the actual width in real life. You can solve it with cross products, or I'm going to use scale factors. To go from the numerator to the denominator in my ratios, I would multiply by 2. So to find x, I would do 4.5 times 2, which is 9 meters. So now to find the actual area, it's a rectangle, so I would multiply those together. The area is length times width, so I would do 20 times 9, which is 180 meters squared. So that's the first way. First, converting to find the actual length, the actual width, and then multiplying them together to find the area. The second way goes back to looking at our scale factor, which remember we said is 200. So to find the new area, and the actual area, you square the scale factor and multiply by the original area. So my scale factor we said was 200. So I'm going to do 200 squared times the original area, which was 10 by 4.5. Multiplying that out, 200 squared is 40,000 times 45. And when I do that, I get 180, or 1,800,000. And I would label it centimeters squared. Well, that's interesting. I have a different answer, but you have to really look at the labels. This answer was centimeters squared, where my previous answer was meters squared. So that's why it looks like a different value, but if I convert them, they would actually be the same answer. Looking at question 2. The pair of figures is similar. What is the ratio of the perimeter from the left square to the right square? So the ratios of the perimeters is the same thing as the ratio of the original side lengths. So that would be the same as 15 for the first one compared to 18 for the second one. And if we reduce that, that reduces down to 5 to 6. Part B, what is the ratio of the areas from the left square to the right square? So instead of just doing the scale factor for area, you have to square it. So I do 5, 6 squared which ends up being 25:36. So the perimeters are the same as the ratio. The area are the squares of the ratio. Looking at question 3, the pair of figures is similar. The area of the larger triangle is 185 feet squared. Find the area of the smaller triangle. So if I look at these two ratios, because they're similar, I can look at the ratio 14:4. And then for the area, I would have to square it. So using my calculator to do that squaring work for me, 14 squared is 196, and 4 squared is 16. If I reduce that, let's see, what's that reduced to? It reduces to 49:4. I can now use that to multiply the smaller rectangle, or the smaller triangle. So the area of the smaller triangle is what I'm trying to find. So that area times that square that we just found, the square of the scale factor, is equal to the larger area, which we found was 185. That's what they told us. So now I can do my inverse work. Divide by 49/4, or you can multiply by the reciprocal. And I get the smaller area. And I do my dividing. Is 15 and 5/49, and the label would be feet squared. Okay, looking at our next example. Triangles CDE and FGH are similar. They tell us they're not drawn to scale, but we have to find the perimeter of the smaller triangle, FGH. Well, first thing I need to do is find my scale factor from the big triangle to the small triangle. So to find the scale factor, I'm going to take the corresponding side, 16 compared to 24, and then I can reduce it down to 2/3. So to find the perimeter of the smaller triangle, I multiply that scale factor by the perimeter of the big triangle. So if I look at triangles DEC, that perimeter is equal to, if I add them up, it would be 24, 24, and 24, which is 72 centimeters. So now triangle FGH, to find its perimeter, I would take the original perimeter of the big triangle and multiply it by the scale factor, 2/3. Using my fraction key and multiplying, I get the perimeter of the smaller triangle would be 48 centimeters. Looking now at the areas, they want me to find the area of the smaller triangle. Well, first I have to find the area of the big triangle. So the area of triangle CDE. I know the base and I know the height, so I do 1/2 base times height. So that's 1/2 times the base is 24 and the height is 20 and 7/800. Multiplying that out, I get the area of the big triangle is 249 and 3600 centimeters squared. I already know from before that the scale factor from the big triangle to the small triangle was 2/3. So let me just write that down again so I have it. So now to find the area of the smaller triangle, FGH, I take the square of the scale factor, so 2/3 squared, times the area of the big triangle, 249 and 3600. So now I'm going to multiply that out. And I'm getting the area of the smaller triangle is 110.826 repeating Hope this video helps. Let me know if you have any questions. Thank you.